So this one is October, November 2021, paper 6, variant 1. We already discussed the first two questions. So we'll start with question 3 today, and 3 and 4 we'll try to complete today. A student investigates the position of image in a plane mirror. So how he's investigating, the procedure is already mentioned. Figure 3.1 shows a ray trace. So you can see how he complete the figure, how he work out the direction of the reflection of the wave. You just have to follow the instruction and complete the figure. So in the first part, figure 3.1, draw a normal. I will zoom out because I have to use the figure as well to complete the point. So figure 3.1, draw a normal to a line MR that passes through the center and label that as NL. So we have this line MR, we have to draw a normal, and the normal means it should be perpendicular to the surface, and label the point at which NNL crosses the MR, that is B. So what we have to do, using a ruler, you will measure this. You will measure the length. Example, if this is 6 centimeter. So what is half of 6 centimeter? It will be 3 centimeter. So at 3 centimeter, I will draw a line. So it should be perpendicular because it's a normal. So it should be perpendicular and it should be at the center. And you have to label the points as well, what they mentioned, because they mentioned draw a normal to a line MR. So we are drawing a normal to line MR that passes through its center. So it should pass through the center. That is done by measurement. That should be done by measurement. And label the normal as NL. So we label the normal as NNL. And the point where it crosses, the point where the normal cross MR, we label that point as B. And when we are marking the point, you should use small dots, not like this. So the reason is that because we have to sometimes use those dots or points to draw further lines, so it won't be accurate. That's why use the small dots and use thin lines as possible. For the drawing questions, try to use thin lines as possible. Then draw a line 7 centimeter long from B. So we already know this is B. So we have to draw a line 7 centimeter from B at an angle of incidence 70 to the normal MR, to the left of the normal. So this is the right of the normal, this is the right side of the normal, and this is the left side of the normal. And we have to draw a line at an angle of incidence 70 to the left of the normal. So to the left of the normal, you will place a protractor. You will place a protractor and mark 70, like there will be 0, 10, 20, 70, somewhat here. And you will draw a line. What should be the length of the line? That is 7 centimeter. So you will draw a line of length 7 centimeter left of the normal. And this angle is 70 degrees. And we have to label the end of this line as A. So this is already B. So this label is A. Then the second part, draw another line which is 7 centimeter long from B at an angle theta, at an angle 40 degrees to the normal below MR. So it is below MR and to the left of the normal. So we have to draw another line, but this time the angle should be 40 degrees. So the first line which we drew, that was 70. Then we'll place a protractor again and we'll mark 40 degrees. We'll mark 40 degrees and we will draw another line at an angle of 40, and that it should also be 7 centimeter. And we have to label the end of this line as C. So this point we'll label as C. These type of questions are relatively easy, just you have to follow the instruction correctly and complete the figure. Then part B, draw two neat crosses. So we have to draw neat crosses for 2 points, 2 pins P1 and P2 on line AB. And whenever you're drawing crosses on the line, like showing the position of the pins, so remember one thing, that the distance between the pins should be 5 centimeter or more. It should not be less than 5 centimeter. So we have to mark two crosses to show the position of the pins like P1 and P2 or P2 and P1. But remember, even in exam that you are doing with measurement, this distance should be more than or equal to 5 centimeter or 50 millimeter. It should not be too small. So we mark the two crosses to locate the position P1 and P2. Then we have to complete the figure, the remaining part. Then a student places the mirror on line MR and he views the image of P1 and P2. He then places P3 and P4. Draw a line through the P3 and P4 and continue until it meets MR. And measure the angle alpha between MR and NL. So what we have to do in the question, we have to draw a line, as you can see. In part C, they mention draw a line through P3 and P4. So we have to draw a line P3 and P4 and continue until it meets MR. So until it meets MR, we have to draw and measure the angle alpha between NL and MR. Include the unit as well. So what we have to do, we have to just draw a line first between P3 and P4, like line which is joining P3 and P4 until it meets MR. So this is point P3, this one is point P3, and this one is point P4. And we join them until it meets this line. Then the second part, we have to measure this angle. This angle is known as alpha. We have to measure the angle between the normal and this line which we drew. And according to the question, we call this angle as alpha. So using a protractor, you have to measure this angle. You will place a protractor in this manner. And this line will be 0 for you. So 0, 10, 20, 30, 40, and so on. So we'll measure the angle for or value for alpha. It can be any number depending on your drawing. So maybe example 70, 71, 72, any number it can be. I'm taking as 70. And it should be about 70. The reason is that because in the first figure, we took angle of incidence. When angle of incidence was 70, so angle of reflection should be 70. Not 100% accurate, but it should be around 70. Then the next part, so we have to write here the angle, measure the alpha between the line and the normal. So we measure this angle, and that is about, and measure the angle alpha between a line and the normal and NL, and below that, so we already did that, it was about 70. Then student places the reflecting face of a mirror vertically on line AB. So student changes the position of the mirror. He then places P1 and P2 on line CB. and draw a line to join the position P5 and P6 and continue until it meets NL, and measure the angle between the normal and MR. So the same we have to do, like this was we already joined P3 and P4. Now what we have to do, we have to join P5 and P6. So P5 and P6 in line, we join them together. Then the next part, after joining P5 and P6, what we have to do? Draw a line joining position P5 and P6 and continue until it meets NL, the normal, and measure the angle beta, that was alpha, so beta between the line NL, between the line and NL below MR. So we have to measure this angle. So we have to work out according to the question, the angle between the line, this angle between NL and MR, we have to measure this from a normal. And that angle, what we called that angle as beta. Then the last part, a student investigates the possible relation between alpha and beta. The angle theta remain 40. The suggest value for angle of incidence he could use. So how we can suggest the angle of incidence, what he can use? So as you can see, student investigate the possible relation between alpha and beta. So what is the possible relation between alpha and beta? Example, say alpha was 70 degrees. It depends on the value because you can only work out the possible relation from these values. So example, alpha was 70 degrees, which we work out, and beta example, it was 80 degrees. That what we measure the angle between the line NL, line and the NL below MR, and we mentioned the unit as well. And a student investigate the possible relation between alpha and beta. The angle theta remain constant, so theta remain 40 degrees. Suggest a value of angle of incidence that he could use. So in the first experiment, he used angle of incidence equal to 70. So if he use angle of incidence equal to 70, he can use any value of the angle of incidence. Like example, he can use, like example, 20 degrees, 30 degrees, or 50 degrees. Or he can use example 10 degrees or 15 degrees, 20 degrees. So these are the suggested value. Like repetition is there. If the angle, what is the angle of incidence? So we can repeat the experiment with different values for the angle of incidence. So 10 degrees, 15 degrees, 20, 25, 30, many possible values are there. Then a student does this experiment with care, suggests one practical reason why the result may not be accurate. Whenever we are doing the experiment in which we use the pins, in which we draw the lines and using a mirror, so what are the possible sources of errors? Number one, thickness of the pins. Because if I'm using thick pins, then what will happen? It won't be accurate. Why? Because I can draw multiple lines if I'm using a thick pins, so it won't be accurate. Same thing, thickness of the line. When we are drawing the line, maybe the pins are thin, but when we are drawing the line, we are using thick lines. So if we are drawing using a thick lines. So the angles, when we are measuring these angles will not be accurate. It will be different. And another possible source of error is the thickness of the mirror. If you are using a thick mirror, then it won't be accurate. So these experiments related to pin and reflection, in which we are using the optical pin to study the reflection, what might be the possible sources of errors? It might be a thickness of line, thickness of mirror, thickness of the pin. And I have already shared these sources of errors related to each experiment. I shared the unit 6 file with you, the paper 6. So you can go through that, all the sources I mentioned in that, possible sources of error depending on the experiment which we are performing. Then what we have to do in this question, tick the boxes that indicate the relevant precaution that students should take with this type of experiment. Carrying out experiment in a dark room, that is not correct. Like, that is not the precaution, because it should not be dark room experiments which are performed in a dark room. If we are using a light source like bulb, lamp, laser, those type of experiments should be done in a dark room. That's why this is not the right way. Drawing thin lines, yes, when we draw thin lines, our experimental accuracy will be more, or that is the right relevant precaution. Keep one eye closed. That is also right, because to identify the correct position of the pin, you should always keep one eye closed and look from the other, so you can correctly identify the position. Keep room temperature constant. Here, temperature is not affecting the experiment. That's why it is not a relevant. View the base of the pin. That is always correct, because when to identify if two pins are in line with each other, whenever we want to identify whether two pins are in line with each other, we should not look their tops. That is not the right way. We should always look at their base. The reason is that because base is always fixed. So maybe the pins might be tilted. So if you are looking at the base, it will be accurate, because the bases are always at a fixed position. So whenever we want to identify the accurate position of the pins, or looking at the pins, we should always view the base of the pins. So this was the experiment related to finding the position of the image formed by a plane mirror. So you just have to follow the instructions which are given, and using the instruction, you can simply work out the position of. Then question 4 is about the planning of experiment. A student investigate the time taken to heat water in different uninsulated container. Like containers are there, they're not having any insulation, and we are finding how much time it will take for uninsulated containers for water to heat up. The containers have the same volume and they have the same shape. The water in a heater, water is heated with an electrical immersion heater. The following apparatus is available. We have a selection of a containers, variety of containers are there, measuring cylinder, thermometer, supply of a cold water, immersion heater with a power supply. Plan an experiment to investigate the time taken to heat the water in different uninsulated container. You should list any additional apparatus what you need. Briefly, how would you carry out the investigation? State the key variable that you keep constant, and draw a table or tables with a column heading which display your results and the reading. You don't have to mention the numbers, you just have to mention what quantity you will use, which quantities you will measure for the experiment, and explain briefly how would you use your readings to reach a conclusion. So the main experiment, we are investigating the time taken to heat water in different uninsulated container. So first, what is the additional apparatus we need? Because we want to, according to a question, they already mentioned the list of apparatus, but one important apparatus which is missing here, as we want to measure the time. So you don't see a stopwatch here. So list additional apparatus. In exam, when you are answering this question, the best way to answer is like try to answer each point rather than writing a whole experiment. So list at any additional apparatus what we need. So we need a stopwatch to measure time. That is the first part. Then briefly explain how you will carry out the experiment. So what we will do, we will take a measuring cylinder and we will transfer the liquid into uninsulated cup and we'll measure the initial temperature. And we have different additional cups are there, uninsulated cups are there, they are same size. And the main experiment, as you can see, that investigating the time to heat the water in different uninsulated container. And the containers all have the same volume and shape, but their material is different. Like example, one is maybe made up of polystyrene, another one is made up of glass, one is maybe made up of copper. So we will take equal volume of the water and transfer into 3 or 4 different containers. We'll measure the initial temperature and we'll place an immersion heater and switch on the heater, like example, for 2 minutes or 3 minutes or 5 minutes and record the final temperature. So the second part is the procedure. We will take equal volume of water and transfer to 3 different uninsulated containers. Then we will place the immersion heater, record the initial temperature. And start the timer. Record in initial temperature and we will place the heater and we will start the timer and as well as the heater. Until it reach like certain value, like example 20 degrees, 50 degrees, or say example 40 degrees. This is the second part. State the key variable that you would keep constant. What should be the key variable? You will keep constant the volume of the water used for each experiment. That should be same. The volume of the water for each uninsulated container and the initial temperature, the starting temperature. So the starting temperature should also be same. We should start with the same temperature and we are reaching a final temperature. So basically we'll compare which one is a better insulator, uninsulated cup, like we'll compare the time. The one which take a longer time to reach this final temperature around 40, it means that is providing or that is losing more energy to the surrounding. The one which take less time, so means that is taking, that is not losing too much energy to the surrounding. That's why it reaches the 40 degrees in a short time interval. Then what table, the column, this part, draw table or tables with a column heading to show how you display your readings. Again, as I mentioned, you don't have to write the number, but you have to mention that what are the variables, what are the quantities you are measuring. So we can make one column is for uninsulated container, and the second column, even two are enough here because we are not measuring too many quantities. We are measuring how much time it took to reach this 40 degrees, and it can be any other temperature you can select. So we'll make two columns, and whenever you are using a column, it should be with a column heading, means the quantity with the unit, that is a column heading. So time, that is in second, and the uninsulated container, that is not having any unit. So you can have uninsulated container A, uninsulated container B, and an uninsulated container C. And you're measuring how much time each container took so that the water temperature rises to 40 degrees or 50 degrees or any specific number, a specific value. Then briefly explain how would you use your readings to reach conclusion. How we'll reach our conclusion or how we'll make a conclusion for this experiment. So we'll compare the duration or we'll compare the time for various container. The one which take a longer time, it means that is not a better insulator, like that is losing more energy to the surrounding. The one which take a short time to reach the maximum temperature, it means that is not losing energy to the surrounding. So how we reach our conclusion, we'll compare the time for each container. The container which take less time to reach the maximum temperature, does not lose energy to the, or does not lose too much energy to surrounding. So this was the whole experiment. As the main experiment, this is how you write the experiment. The first, always try to answer according to the points which they ask. Any additional apparatus, so we mentioned that. Then the procedure, explain how we carry out, so how we carry out the experiment. Then the variable, so it's a plural, so we have to write at least two. Then the table or tables with a column heading, and then how would you use your readings to reach a conclusion, or how you make your how you will reach a conclusion or how you get the result for your experiment. So student investigate the time taken to heat a water in different uninsulated container. The container all have the same volume. So we have to plan and investigate the time taken to heat water in different uninsulated container. Like how we know like which uninsulated